Our new topic today is talking about friction. Friction, in a very simple word, we have someone pushing a box. So you are applying a force in this direction. Let me ask you, what do you expect? This box will not move. The box would like to move, but it will not move. Why? You have applied force here. Why this box did not move? Because we have something here at the ground between this box and the ground surface, or any surface, the contact surface. We have something here called friction. That makes sense? If the ground is more smooth, the friction force will be less. If the surface is more rough, the friction will be more and more. I need you to learn two words. The first one, where is the direction of the force? In this way, the direction of the force applied to this box in this direction. That means the friction will be in the opposite direction. The friction force will be in opposite direction to the force intended to move this box. The value of this friction force equal. The value of this friction force equal mu time n. We are done with this topic. Just a few words. We have a friction force between two surfaces, body and the ground surface. This friction force is opposite to the applied force. How much? Mu time n. What is the meaning of mu? It's the coefficient of friction based on the type of material in contact. As I told you, probably the box is rested on ceramics floor, or on wood floor, or on metal floor. So these different surfaces will affect how much friction do you expect here. So this mu called coefficient of friction, and this value depends on what is the type, or what is the type of material at the contact surface. N is the normal force perpendicular to the surface of contact. Guys, I have a question. This box has a weight. Do you think if this weight is too much, what will be the friction force? What do you think if this weight is very light? What do you think about this friction? I think if this weight is too much, the friction will be too much. If this weight is light, the friction will be less. So this N, I will not say it's the own weight, but I will say it's the vertical force perpendicular to this surface. For example, if you have somebody standing on this box, what is the vertical force perpendicular to this surface? Is the weight of the box and the weight of this body. That makes sense? So from this slide, I need you to learn 2 points. The first one, the friction force direction opposite to the applied force. The second one, the friction force equal mu, which is called the coefficient of friction, time N, and this N is a force perpendicular to the surface of contact. Perpendicular to the surface of contact. Make sure I didn't say N is the vertical force. I didn't say this. I said N is the normal force perpendicular to the surface of contact. Why you are saying this? Because sometimes you have inclined surface and you have a box here. The weight of this box, any weight in this world, is vertically down. Do you think this weight equal N? No. Why? Where is the contact of surface? Here is the contact surface. Contact surface or surface of contact. N must be perpendicular to this surface. So please remember this point. N in this equation is the normal force perpendicular to the surface of contact. Anybody has any question until this moment? Yes, I did. I think June. Oh my goodness, I didn't? No way. I'm so sorry, I forget it, probably. Yeah, I did. Module number 8, November 2nd. Yeah, I did. Let me open it. Yeah, I did. Okay. Any questions so far? Friction force. As I told you, friction force equal mu time N. So I have question. What are the factors affecting the value of this friction force? What do you think? What are the factors? What are the factors? The first factor is the condition of the contact surface. Is it smooth or rough or very rough or very smooth, which depend on the value of mu. This table can give you some values for mu. We will not use them because mu will be given in the problem. Don't worry. The second factor is the weight. Not weight, but the normal force perpendicular to the contact surface or the surface of contact. So normal force, which is how much? Which is perpendicular to the surface of contact. This line is very important. Friction force is independent of contact area. Guys, I don't care if you are pushing box with this area or another box with this area of contact. If you push this one or push this one, can you watch, please? This contact area, too large. This contact area, very small. I don't care. I don't care about the area. It's not a factor. The factor is mu and N. N is the weight or the force perpendicular to this surface. N is the force perpendicular to this surface. So the only two factors affecting friction force is the type of contact surface and the weight perpendicular to this surface. So I don't care about what is the area of contact surface. Is it too large, too small? I don't care about this point. Okay, it's not a factor. So friction force is not or is independent of contact area. Any question? Actually, in this course or in this topic, we have two situations. The first one, the box is under the effect of a force on horizontal surface. Or this box under or over inclined surface. Let's start with the first one. Horizontal surface. Guys, anybody can tell me where is the weight of this box? At the centroid, at this point. What is the direction? Any weight in the world, any weight on this Earth, on this planet, is the vertical direction to down. This force trying to push this box to right. So I believe I will have a friction opposite to the applied force. That makes sense. So this friction force equal mu time n. Probably mu most of the time is given. What is the value of n? Just to remind me, what is the meaning of n? N, it's not vertical force. It's not a horizontal force. N is a force perpendicular to the surface of contact. Where is the surface of contact? Where is the surface between this ground and this box? I think the contact of surface is this horizontal line. Which force perpendicular to this surface? Weight. So in this case, the weight is the same value for n. Why? Because the weight is, you are lucky, is perpendicular to the surface. Any question? Any question? Looks good. Let's start to do this example. Let's start to do this example. We have a box or crate has a weight equal 200 Newton. So at this centroid, I will have a weight like this. How much? 200 Newton. And we have a force P equal 80 Newton. But 80, it's not a horizontal or vertical. It's inclined force with angle 30 is applied to the crate. The coefficient of static friction mu equal 0.3. To determine the static friction force, what is the value of friction force? And please tell me, the crate will move or not? Guys, I didn't ask you this question. Anybody, I told you here, we have a force and we have a friction. Can you tell me when this box will be moved? This box will be moved if what? I need answer. If what? In another word, I have a box here and I have someone pushing this box. So we expect here friction. Can you tell me when this box will be moved? When what? Or if what? Thank you, Mitchell. Yes, thank you, Jordan. Yeah, that makes sense. Moving will happen if the applied force greater than friction force. Static equilibrium, no movement, if the applied force smaller than friction. You are trying to push the box, but no way. Does not. There is no moving. Why? You are applying a force, but there is another force which called friction greater than your force. Okay? So this problem is asking for what is the friction force? Tell me what is the value, and tell me, do you think this crate will be moved or not? Okay, let's start. Guys, where is the force which is trying to push this crate? I think this inclined force will be resolved to two components, one horizontal and one vertical. If you go back to module number 1 in this course, the horizontal value will be 80 cosine 30. The vertical one will be 80 sine 30. This value will be 69.3, and the second one will be 40. So this horizontal force, which is 69.3 Newton, would like to push this crate to right. So I believe I will have friction force in this direction to left at this contact surface. The contact surface is a horizontal surface. So your friction value equal mu time n. Guys, can you tell me what is the value of mu? Is given 0.3. Can you tell me what is the value of n? Just to remind you, n, all forces perpendicular to the contact surface. I didn't say before it's the own weight. I didn't say this. I said n is the force perpendicular to the contact surface. So can you tell me what are the forces on this crate perpendicular to this surface? We have this weight, that's fine. Is it the only force? No, we have a vertical component here, 80 sine 30, which is 40 Newton. So N will be 40 plus 200. This is the weight, this is the vertical component, 240. 240. So this value will be 72 Newton. So the first part in this problem, what is the value of the friction force, is 72 to left. To left. this direction opposite to the applied force. That makes sense. So I need answer right now. We are pushing this crate with a force 69.3 Newton. And the friction at this surface is opposite to this force. How much? 72. Do you think this crate will be moved? No. Because your pushing force is 69, but the resisting force, which is friction force, is 72 Newton. So no movement will be happened. Thank you. Jordan, the vertical force, it's not only 200, it's 200, and we have vertical force here, vertical component 40. Please remember this rule. In all forces, please don't forget any, all forces perpendicular to the contact surface. Okay? Any question?